Welcome to Solving Time Value Money Problems with the BA2 Plus Financial Calculator. This is the first in a four-part series designed to help you get the most out of this powerful little device. In this video, I'm going to be showing you how to solve any future single sum problem with the TVM worksheet. And when I say any single future sum problem, I'm talking about a problem with a cash flow looking like this. I'm going to show you how to find present value, future value, internal rates of return, or the discount period, which is the number of years in the problem, for every case involving simple interest and compound interest. And that ought to take care of everything you ever need to know about single sum problems, because that's pretty much everything there is to know about single sum problems. We'll get started with some things we need to know about the calculator. First, when you turn it on, it's going to default to the TVM worksheet. So all you have to do is clear it and it's ready to go. There's also a set of dedicated time value keys that we're going to use, and we're going to use all of them with the exception of the payment key. And that's because we're going to save that for the annuity video, which comes up next. But we're going to have to pay special attention to the interest rate key, because the interest rate key is for annual interest only. And if we have compound interest, we have to make a little bit of an adjustment so that we can take that compound interest and use it in that single interest key. That's one of my shortcuts in here. It's easily done. I'll show you how to do it when we get there. When we get the interest rate, we're going to put it in as an integer. That means something like 9% will go in as 9, not 0.09. That makes doing time value problems a lot easier, not having to type that 0.0, put the 9 in. And we're also saddled with this design quirk that the engineers at TI put in the programming, because they thought that whenever we had an investment, we would take money out of our pocket, hence there would be a negative cash flow. And that investment would mature and come back as a positive cash flow. So they decided to devise every single problem that is done with the TVM worksheet as having a negative sign, even though that negative sign happens to be mathematically meaningless. So we're going to have to learn how to use that mathematically meaningless minus sign and ignore it at the same time. Takes a little getting used to, but you'll get there. I'm also going to show you a shortcut, which is really neat. It'll cut through some of the stuff that the user manual says we should do. So let's begin with our first problem, and we're going to find the future value of $100 invested today at 9%, compounded annually. Now, whenever I see a time value problem, first thing I like to do is to draw a little sketch like this of the problem, and that helps me get the numbers in the right place. So I've got present value of 100. And I'm looking for a future value, and I've got 10 years, and I've got the 9%. Now, another reason for doing it this way is because the four regions in this diagram correspond to the four values in the simple future value equation. For example, we have a future value in both present value, an interest rate, and an N. Now, the N is always going to be the number of compounding periods in the problem. And if we have annual compounding, that will also end up being the same as the number of compounding periods in the year. But think of it as the annual compounding periods in the problem. Now, if we're just doing the algebra, you know that if we have values for three of these four variables, we can solve the problem. That's the way the calculator is designed. So let's get rid of the algebra and start with the calculator, and we'll clear it. And let's put the values in. Put the 100 in as a negative amount. Well, why a negative amount? You can see I have a positive number here on my axis. That's because of that design quirk. Now, either I put that minus sign in and get rid of it so that the answer comes out positive, or if I put that in as a positive, then and work the problem through, then the calculator is going to put that minus sign in my answer and make it negative. And I like positive answers, so I'm going to get rid of the negative immediately. Put the 9 in as an integer. That's the interest rate. The 10 ends the n. Compute the future value, 236.74. All right, let's redo the problem. And this time, let's, same problem, same diagram. Let's put something different in. Let's do the 9% compounded weekly. So whenever I see a problem that has compounding other than annually, I like to flag it. I might circle it, underline it, put a star beside it, just do something to remind me that when I get to that interest rate key on the calculator, I will take the time to work it out. So I start the calculator, I put the 100 in as a negative amount, I get to the interest rate. Now, remember that interest rate key is for annual interest only, and I have a problem with compound interest. And I want to convert 9% compounded weekly into a single interest rate that would be exactly equal to 9% compounded weekly. When I do that, I can take that interest rate and plug it into the calculator. So that single interest rate that's equal to 9% compounded weekly is the effective rate of interest. And it's easily computed. All I do is I divide the 9% by 52, add 1, raise it to the 52nd power, subtract 1, then I have the decimal equivalent of the interest rate, and I have to put everything in the calculator as an integer, so I have to multiply that decimal by 100, and I'll get the interest rate. And look at the calculator display. See where it says 9.41? Well, what I've done is I have stepped away from the worksheet, and I've used the calculator as an algebra calculator. And I haven't saved that into the worksheet yet, and it won't go in until I tap that interest rate key like this. Tap the interest rate key, and now you can see the display says interest rate is equal to 9.41%. Okay? Back up, I can use the calculator as an algebra calculator. Once I get my number, I tap the interest rate key, I'm all set to go. One other thing, don't worry about losing any decimals due to rounding. You can see that we've rounded up here to 9.41, but the calculator will carry every calculation out to 13 decimal places. So it's only showing you 2, because I've programmed the calculator to show me 2. It's only showing you 2. It hasn't forgotten all the decimals behind it. Let's go back, put in the n, compute the future value, it's 245.77. No surprise there. It ought to be a little bit bigger because the interest rate is compounded, so it's money's growing just a little bit faster. It's not going to be 236.74, it's now 245. Let's take a look at the way the user manual does it, because the way I just showed you is not the way the user manual will do it. And I don't want to get any nasty letters from the TI guys saying that I didn't show you the right way to do it. So here's the way they did it, with a lot more keys. They made use of the P/Y key, the down arrow key, and the times P/Y keys. And they did it in combinations that would take us to different menus. For example, if we use second PY, then the display will say PY equals, in your calculator, if you're following along, will probably say 1. And it should say 1 if we're working this problem, because that's the number of payments per year. P/Y, payments per year, 1. Now we're going to use a combination of 3 keys, and that's going to be second PY down arrow key. That brings up the C/Y menu. That C/Y menu is for the number of compounding periods in the year. Now, your calculator may say 1 right now. Don't worry about that. When we do the problem, we're going to change that to 52 because we're doing weekly. Then we put our interest rate in, and we use a combination of second times PYN, and that will establish the number of compounding periods in the problem. So let's get rid of the calculator, and let's do the algebra according to the user manual solution. And we'll start off with second PY. Now you want to make sure that there's 1 in the display. If there is, you hit enter second quit. That saves it to the worksheet. If there's not a 1 there, put a 1 there. Okay, you have to have one there. You have one payment per year. Now we use the combination of 3 keys. Second PY down arrow key, 52. And that's because we have 52 compounding periods in the year. That's always the interest in the number of compounding periods per year. Then we want to save that, so we hit enter second quit. Now we put the number of years in as 10. Hit second times PYN. And we can now finish the problem with the regular numbers. For example, the 9% is the interest, and the $100 is a negative amount. And we can compute the future value at $245.77. That's the exact same interest number we got a minute ago. But we're not done yet, because we have programmed the calculator for 52 compounding periods in the year. Unless we change that, every problem that you work from now on is going to have 52 compounding periods in the year, and you're not going to know about it. You can't get rid of that by shutting the calculator off and turning it on. You can't get rid of it by hitting second clear TVM. It's always going to be there. So you get rid of it with a statement. Second PY, second clear worksheet, and that takes us to the end of the user manual solution. That's how they would do it. Now, if you don't want to use the second PY, second clear worksheet, you can hit second reset enter. That would do it also. But remember, you have to do one of those two, because nothing else will get that 52 out of the calculator. And you can't even see it. It's just going to be there, and it's going to mess up all your problems because they're going to be off just a little bit. That's why I like the shortcut. Because when I do the shortcut, the only thing I've really done that's different is I've converted the stated annual rate into an effective annual rate. That's easily done. And once I get that in there, you see, I don't have to do any of that programming it for 52 compounding periods. I don't have to worry about deprogramming it. And, sometimes you can just forget to clear the calculator when you're done. You may get all excited about using the user manual solution and write 245.77 down, and then go on to the next problem and forget to clear it. Well, you don't have that problem with a shortcut. You are going to have to use one of the two. You're going to have to decide which one to use in the future whenever you have compound interest. Let's do present value. Okay. You probably are going to start knowing the answers to some of these problems, because now you've got 236.74 out there as the future value, and you want to discount it at 9% annually. Okay. What's it going to be in a present value? Well, you have the 9% and you have the 10 years. Looks like you have 3 of your 4 variables. Open your calculator, put the 3 of the 4 variables in, and compute the answer. Comes out to $100. No surprise there. Now, what would happen if I didn't put that 236.74 in as a negative number? What if I forgot and put it in as a positive number, like this? Then my answer is going to be negative. Got it? So if I put it in as a negative, answer is positive. If I do it the other way around, the answer is going to be negative. I like positive answers, so I will always try to get rid of the negative sign just as soon as I put a number into the calculator. The other thing that we can see here is that we have a new term called discounting. And the only difference between discounting and compounding is the direction that you're moving on the time axis. So if you are using the interest rate to grow $100 in time, you're compounding. If you're using the interest rate to make 236.74 shrink in time, that's discounting. Difference between the two. Let's do the third problem. We have 10 years, 9% compounded monthly. All right, now, same type of problem we had before, only I'm going to use my shortcut. And here's my shortcut. I have monthly compounding, so it's 12 months. So this time I'm dividing my interest rate, which is 9%, by 12. And then I'm adding 1. Then I raise it to the 12th power, because 12 compounding periods in the year. Subtract the 1, I have the decimal value. Multiply that by 100, I have the integer. Tap the interest rate key, it is then saved to the worksheet. And my present value is 100. Well, why do I do it this way? Well, I want to show you that this shortcut method of using the effective rate of interest works both in the future value and it works in the present value. So if we were to compare the shortcut that I just did with the user manual solution, again, the user manual solution is just the same as before. So the user manual solution is identical, whether you go ahead in time or whether you go back in time. See, we're using the 12 compounding periods in the year, and we also have to make sure that we clear over here, or we can use this statement over there to clear it. So the shortcut works both ways, forward and backward in time. The internal rate of return. Now, you'll know the answer to this problem too, even before I put it up. So I'll draw a picture anyway, and I have $100 in the present, and I have $236.74 separated by 10 years. And I want to know what is the internal rate of return. In other words, what interest rate would take that $100 and compound it annually for 10 years and leave me with exactly $236.74, or what annual interest rate discounted for 10 years would leave me with exactly $100. Well, we have 3 of the 4. Put them in. The answer is going to be 9%. But you knew that. We have one more term. We have the internal rate of return. And that's just another name for the interest rate. And I point this out because sometimes when people are first working, time value problems or finance problems, they wonder, is the discount rate any different than the internal rate of return? The answer is no, it's all the interest rate. The interest rate can be the compound rate, the discount rate, or the internal rate of return. It just depends upon what you are doing with that interest rate or whether you're asking for it, and that would be the internal rate of return. What happened here? Wait a minute, let's go back one. Okay, now I've got my numbers in positive. $100 is a negative amount, $236.74 is a positive, and 10. By the way, I could have put either one of these two numbers in as a negative. It didn't make any difference, okay? Just one of them has to be negative because we have to have a negative sign somewhere in the time value problem. So I work it out and we'll go ahead, and now it looks like I have them in a different order. And it turns out, yes, that's easily done. It doesn't make any difference what order you put these values in. I like to put the number in as a negative as soon as I can, and I follow it with the interest rate and then the n. You can do it differently if you want. Doesn't make any difference which order you put them in. The other thing I would show you here is that you can also change any one of these variables without having to change the others. So you might say, gee, what if I wanted that $236.74 to be $300 instead? Would I have to go back and restart the calculator over and then start the 10 in again, put the 100 in again? The answer is no. Just put the 300 in as a negative number. Don't forget the negative number. Compute the internal rate of return. It comes out to 11.61. The discount period is another problem that you'll know the answer to, because I have $100 separated by an unknown number of years, and the number in the future is $236.74, and I have 9% in the middle. So 9% connects the two. It's what I use to compound $100 ahead, or it's the 9% that I use to discount the $236.74. How many years are in that? And the way I find that is with this. Clear the time value memory, put in the 3 that I have, ask for the 4th, and of course there's 10 years. That takes us to everything that I can tell you about the single sum problem. And I've shown you how to find present values, future values, internal rates of return, discount period, in cases where your interest is simple interest or compound other than annually. That covers pretty much everything there is to know about that. Although I would say that the user manual says that anytime you have this single sum problem with compound interest, the user manual says, well, handle the compound interest this way, And I said, I think you can handle the interest that way, over there. That's up to you. You're going to have to use one of the two of them. Now I'm going to leave the second row for the next video, which deals with annuities. And if you learned anything in this video, I think you'll learn a lot more in the next video where we deal with annuities. And there's new wrinkles there too. You'll be surprised. So I will see you in the next video.